Hello friends, in this video we are going to discuss about a book which is Engineering Entrances Objective Physics. This book is written by DC Pandey, and in this whole course we are discussing in detail about various books, and this is helpful for students who are in the intermediate or who are preparing for any competitive examinations. And most of the students in many colleges they do not prefer books, they only guided by notes and other study materials. But the book reading is a very good habit and it will clear many concepts. And this video series will helpful for the learners who are um, not able to read books due to different reasons. So this whole series contains a lot of books, in detail analysis of those books, and it might helpful for the viewers. Starting the first book, this is Objective of Physics. This is volume 2, and the course content of this book is more or less about electricity and magnetism. Then electrostatics, first chapter is electrostatics, and talk about electric charge, conductor, insulators, charging of a body, then Coulomb's law, then electric field, then potential, then about the equipotential surfaces, then electric dipoles, little about conductors, okay, and then electric field and potential due to charged spherical cell of solid conducting sphere. And then I talk about some capacitance, then method of finding the capacitance, okay. So let us discuss the first chapter, that is electrostatics. First we discuss about electric charge. The electrical nature of matter is inherent in atomic structure. An atom consists of small, relatively massive nucleus that contains particles called protons and neutrons. A proton has a mass of 1.673 into 10 to the power minus 27 kg, while a neutron has a slightly greater mass of 1.675 into 10 to the power minus 27 kg. Surrounding the nucleus, there is a diffuse cloud of orbiting particles called electrons. An electron has a mass of 9.1 into 10 to the power minus 31 kg. In this first paragraph, the writer talking about the mass of proton, the mass of electron, and the mass of neutron, and talk about the structure of atom, how atom consists of a central nucleus and surrounded by the electron cloud, and the central nucleus consists of protons and neutrons, okay. Like mass, electric charge is an intrinsic property. It is an intrinsic property. It is a fundamental property of protons and electrons, and only two types of charge have been discovered, namely positive and negative charge, okay. There are two types of charges we are discussing. One is positive charge, other is negative charge. A proton has a positive charge. Proton is assumed to be positive charge, and electron has a negative charge. A neutron is neutral. A neutron has no net electric charge. The magnitude of charge on proton exactly equals the magnitude of the charge on the electrons. The magnitude of the charge of proton is exactly equal to the magnitude of charge of electron. They contains equal and opposite charges of equal and opposite sign. The proton carries plus E and the electron carry minus E. Okay. The SI unit of charge is coulomb, and electron has the value of 1.6 into 10 to the power minus 19 coulomb. Regarding charge, following points can be considered. What? Like charges repel each other. Positive charge repel each other. Negative charge repel each other. And unlike charge attract each other. Charge is a scalar quantity and can be of two types, positive or negative. Charge is quantized. Quantized means, what is the meaning of quantization? Quantized means the quantum of charge is E. The charge on any body will be some integral multiple of E. That means Q. This Q can be written as plus or minus N into E. And E is the charge of electron. This is a quantum of charge. And with the multiplication of N is an integer starting from 1, 2, 3, etc. And this is the quantization of charge. That means the charge can never be 1 by 3 E, 1.5 E. So charge should never be fractional form. It should be an integral multiple of the quantum of charge, that is E. Okay, this is the charge quantization form of charge. Apart from charge, energy, angular momentum and mass are also quantized. Not only charge, energy, angular momentum and mass are also quantized. The quantum energy is h nu and the angular momentum is h by 2 pi. Quantum of mass is yet not known. The protons and neutrons are a combination of entities called quarks. They are called what? Protons, neutrons, and electrons are called fundamental particles, and they are called subfundamental particles. If we divide the protons and neutrons and electrons, we will get quarks. We can say that protons, neutrons, and electrons, they're combination of different quarks. Okay, so we can say which have charges 1 by 3e or 2 by 3e. That means that is the fractional multiple of charge. That means we divide the fundamental charges here, we'll get quarks. And you will get knowledge of quarks in a more detail in further higher classes. However, isolated quarks have not been observed, so quantum of charge is still E. So we do not get isolated charge, isolation form of quarks. So quantum of charge is still E. During any process, the net electric charge of an isolated system remains constant, or we can say that charge is conserved. There is pair production and pair annihilation are two examples of conservation of charge. In a pair production and in a pair annihilation process, the charge is conserved. In any process, the charge is conserved. Okay. And fifth point, a charged particle at rest produces electric field. A charged particle in an unaccelerated motion produces both electric and magnetic field but does not radiate energy. But an accelerated charge, if the charge is in the form of acceleration, not only produces electric field but also magnetic field but also radiate energy in the form of electromagnetic waves. If a charge is rest, it produces only electric field. If a charge is on accelerated motion, it produces both electric and magnetic field but do not radiate any energy. But if accelerated charge produces both electric and magnetic field, as well as it radiates energy in the form of electromagnetic wave. And if we talk about 1 coulomb. It is an electrostatic unit in a CGS unit, that is 3 into 10 to the power 9 electrostatic unit, and 1 by 10 electromass unit of charge. So remember this value for the problem solving purposes. It is 1 coulomb is equal to 3 into 10 to the power 9 ESU is equal to 1 by 10 EMU of charge. Take our first example. How many electrons are there in 1 coulomb negative charge? 1 coulomb of negative charge consists how many electrons? Okay. We know the formula from the quantization of charge, that is Q is equal to NE. We apply this formula here. This formula is applied here. This formula is applied here. That is Q is equal to Q is equal to NE, and N is equal to Q divided by E is equal to, we know that is 1 coulomb of charge, that is Q is 1 divided by E. E is 1.6 into 10 to the power minus 19. So we'll get the value 6.25 into 10 to the power 18. This number of electron consisting 1 coulomb negative charge. In conductors and insulators, for the purpose of electrostatic theory, all substances can be divided into two main groups, that is conductors and insulators. In conductors, electric charges are free to move from one place to other place. Charges are free, completely free to move from one place to other place, whereas in insulator, they are tightly bound to their respective atoms. In an uncharged body, there are equal number of positive and negative charges. The examples of conductor of electricity are the metals, human body, and the earth, and that of insulators are glass, hard rubber, and plastics. In metals, the free charges are free electrons known as conduction electrons. Semiconductors are those materials, they are uh, they are in between the conductors and insulators. They are the third class of material, and their electrical properties are somewhere between those of insulator and conductor. Silicon and germanium are two famous examples of semiconductors. Charging of a body. Mainly, there are following three methods of charging a body. Charging by rubbing. The simplest way to experience electric charge is to rub certain bodies against each other. When a glass rod is rubbed with a silk cloth, the glass rod acquires some positive charge and the silk cloth acquires negative charge by the same amount. The explanation of appearance of electric charge on rubbing is simple. All material bodies contain large amount of electrons and equal number of protons in their normal state. When rubbed against each other, some electrons from one body pass onto the other body. The body that donates the electron becomes positively charged, while that which receives the electron becomes negatively charged. For example, when a glass rod is rubbed with silk cloth, glass rod becomes positively charged because it donates the electrons, while the silk cloth becomes negatively charged because it receives the electrons. One body donating the electron that becomes positively charged, and other body receiving the electron that becomes negatively charged. In this example, when a glass rod is rubbed with silk cloth, the glass rod by donating electron it becomes positively charged, and the silk cloth by receiving electron it becomes negatively charged. Electricity so obtained by rubbing two objects is also known as frictional electricity, because rubbing means friction, that is a friction involved between the two bodies. So this type of electricity is also called as frictional electricity. The other places where the frictional electricity can be observed are when umber is rubbed with wool, or a comb is passed through a dry hair we will also get this frictional electricity. Clouds will also becomes charged by friction process. There is positive and negative charge developed in different layers of the cloud, and the charge is developed in the cloud, and due to that charge interactions will get also thunderstorm. um, and dry hair, we comb our dry hair, then we will also get this type of frictional electricity. In the next video we are discussing about charging by contact and charging by induction. Okay, so thank you for your time. God bless all. And if you get a little bit of benefit from these videos, please subscribe my channel and hit the bell icon.